topic of recurrence relation. Yeah. So in the last class, we've already discussed about recurrence relation and how is it that we can derive, or how is it that we can solve counting problems using recurrence relation. Remember, we solve this specific problem of counting the total number of bit strings of length and that do not have two consecutive zeros using recurrence relation, right? We did that in the last class. So at the first part of the session, we'll do something like this again. In the next example, we'll again solve a counting problem using recurrence relation, just for more practice, just so you get more practice on the process of solving counting problems using recurrence relation. And from then, after that point, we'll end recurrence relation with seeing how is it that we solve the recurrence relations themselves. All right. So let's get to it quickly. So for this example, for this specific problem, we are asked to count the total number of strings made up of n decimal digits such that there are even number of zeros there. Yeah, that is what we are asked to count. So let's suppose that a string made of purely decimal digits, a decimal digit string, let's say it is considered to be valid if it has even number of zeros. Okay. So we are asked to count such strings of length n, such strings which have in total n decimal digits in them. All right. We're asked to count such strings of length n. Okay. So let's say the total count of such strings of length n is represented by an. We're asked to find this value an using recurrence relation. So remember from the last example, how did we find out this value n? How do we use recurrence relation to solve a problem like this? We rely on the preceding values. Remember in the Fibonacci sequence as well. This definition of Fibonacci sequence, what does it do? It relies on the previous two values. We make the assumption that we know the value of fn minus 1 and fn minus 2, and from there we can derive fn. Yeah.
Ma'am, I had a question regarding the assignment.
Can we talk about the assignment at the end of the session, please?
Okay, miss. It was just a question about the time.
Yeah, let's discuss that at the end of the session. I'm in the middle of the lecture. Yeah,
Okay, okay,
so
miss.
thank you. Yeah, so remember the recurrence relation that we use to define the Fibonacci sequence. Here, again, remember that we just assume that if we are asked to find out the value of a certain part of the sequence at some index n, we just assume that we know the preceding two values. That is, we know fn minus 1 and fn minus 2, and from them we can find out the value of fn. And why are we allowed to make this assumption? Because we have defined the initial conditions f0 and f1. Based on the initial conditions, we know that if we know f0, f1, using this recurrence relation, we can find out f2. And once we find out f2 using f1 and f2, we can find out f3. Once we know f3, we're using f2 and f3, we can find out f4, and so on. So that is why, because we have defined two of these initial conditions, we can utilize the two preceding values here in order to derive the value of fn. We can do something like that. So we used that idea to solve the bit string problem, remember? So same thing, we will do the exact same thing here as well. We are asked to find the value of an. Here, for this example, we'll do the same thing. We are asked to find the value of an. First, we will see, is it possible to find the value of an from an minus 1? An minus 1. If we know what an minus 1 is, what is the value? What is the value of an minus 1? If we know that, from that, we can derive the value of an. All right. So we'll see that if that's going to be possible. All right. So I'd just like to remind you that for the bit string problem, remember, how did we use an minus 1 to solve the bit string problem? Remember, what does an minus 1 contain? All the bit strings of length n minus 1. All we did was add a 1 to the end of those bit strings of length n minus 1, and then we have the count of all bit strings of length n that end with 1. We'll use that similar concept here as well. So, assuming that we know the value of an, assuming that we know the value of an minus 1, assuming that we know the value of an minus 1, from here we'll see if it's possible to derive the value of an. Okay, so let's just assume that we know the value of an minus 1. And what is an minus 1, guys? The count of the total number of decimal digit strings of length n minus 1 which are valid. And what do we mean by valid? Read the question again. What does it mean to be valid? That the total number of zeros in the decimal digit string will be even. There will be even number of zeros in the decimal digit string. Assuming that we know an minus 1, let's just first understand an minus 1 je count ache. What bit strings, what decimal digit strings, what type of decimal digit strings is this counting? This an minus 1 contains the count of the total number of n minus 1 length decimal digit strings which are valid, that is, which have even number of zeros in them. So a count, this number is the count of all decimal digit strings of this type, all right, this type, where the total length, that is the total number of decimal digits in the entire string, will be n minus 1, and there will be even number of zeros there, even number of zeros here. As you can see, even number of zeros there, all right? So, if we are talking about decimal digit strings of length n minus 1, which are already valid, that is, which have already even number of zeros there, then we can, just like the bit string example, we can add a decimal digit at the end of this and convert it to n length, right? So if you have a decimal digit string of length n minus 1, and then if we add a number here, whatever number, if you add some number, some digit here, 5, 6, whatever, if you add a digit here at the end, what happens to the length, guys?
It increases.
It increases by 1, right? So if you add any digit here, let's say from 0 to 9, any one of these digits, if you add any one of these digits to a decimal digit string of length n minus 1, the length changes to n. Right? Now, we cannot actually add any one of these decimal digits. Like, that is 0 থেকে 9 পর্যন্ত সবগুলো decimal digit are not available for us as options to add at the end. Can anyone tell me why?
Could you repeat the question?
So here in the question, we are asked to count valid decimal digit strings. Valid. Are valid bolte ki even number of zeros. Knowing that, এই যে আমরা যে বলছি যে একটা n-1 length-এর decimal digit string-এর end-এ আমরা যদি একটা digit add করি তাহলেই তো length-টা n হয়ে যাচ্ছে, তাই না? That is what we did in the bit string problem as well. Same জিনিসটা এখানে করব। এই যে an-1 যেহেতু আমরা জানি, we know the count of an-1. an-1, what is it counting? All the decimal digit strings, all the valid decimal digit strings of length n-1. ওই same decimal digit string গুলাকে আমরা n-1 থেকে n এ convert করব. How will we do that? At the end, we'll add a decimal digit. Now I'm saying যে এই 0 থেকে 9 এই decimal digit এই 10টা অপশনের যে কোনো একটা অপশন অ্যাড করলেই যে হবে, it's not going to be that. We cannot add any one of them. I mean, like 0 থেকে 9, all of them are not available for us as options to add at the end. 0 থেকে 9 পর্যন্ত আমাদের কয়টা অপশন আছে? 10টা অপশন আছে. I'm saying that all of these 10 options are not available for us. That is, তুমি যদি বলো যে 10টার মধ্যে যে কোনো একটা অ্যাড করলে হচ্ছে গিয়ে we get valid কিন্তু valid n length decimal digit string, then that's not correct. Now can you tell me
এখানে তো
why?
জিরো আছে মিস, এই জন্য হবে না।
Exactly. So zero add করলে what is the problem?
মিস ভ্যালিড হবে না এটা।
Exactly, because you see this decimal digit string before you added the digit was already valid. That is ওখানে already even number of zeros আছে. So এখানে যদি আমি এখন 0 add করি তাহলে what happens? Already যদি even number of zeros থাকে আরেকটা 0 add করলে what happens to the number of zeros? It becomes odd. So it's not valid anymore. So that's why you'd have to add any one of the digits from 1 to 9. 1 থেকে 9 পর্যন্ত যে 9টা ডিজিট আছে এই 9টা থেকে যে কোনো একটা you can add at the end to convert this decimal digit string from length n-1 to length n and also keep it valid as well. Valid রেখে n-1 length থেকে n length এ convert করার জন্য you would have to add a digit from 1 to 9, any one of those. Okay. So if you did that, and if you represent all such bit strings of length n, all such valid, decimal digit strings, all such valid decimal digit strings of length n, which end with any decimal digit from 1 to 9, if we represent them using a, right? What is a equal to? A is equal to this count, right? A is going to be equal to this count. Yeah. A will be equal to this count, right? Because we are assuming, first of all, an-1, remember we assume that we know the preceding values. And ওই assumption basis আমাদেরকে initial condition define করতে হবে, declare করতে হবে. So if we know an-1 এর count যদি জানি, what is an-1? an-1 is the count of all valid n-1 length decimal digit strings. এই যে এই কাউন্টের মধ্যে যতগুলো n-1 length এর valid decimal digit string আছে ওই প্রত্যেকটাকেই তো each one of them are being converted to n length valid decimal digit string. ওই প্রত্যেকটাকেই তো convert করা হচ্ছে. So the count remains the same, right? The count remains the same. So does it make sense, guys?
Yes, miss.
Does it? Everyone else? What about the rest of you guys?
The length is changing, but not the count, right? Like if you add one digit at the end.
Yeah.
of n-1.
Yeah. So that's what I'm asking.
Yeah.
The length is changing, but ওই same যে decimal digit stringটা ছিল ওই same digit stringটাকে তো আমি convert করছি and to a valid one nonetheless. So the count doesn't change, right? So that's why we can say that a is equal to an-1, right? A representing all those decimal digit strings of length n which end with any digit from 1 to n. A representing that, A can be equal to, we can say that A is equal to an-1. Is that correct, guys?
Yes, ma'am, I guess. Yes.
You guessed wrong. It's not correct yet. So previously ওই যে bit string এর যে প্রবলেমটা ছিল ওখানের মধ্যে simply ওই যে a is equal to an-1 কেন বলতে পেরেছিলাম? Because we were adding a 1 at the end. Remember ওই যে যখন bit string এর প্রবলেমটা ছিল, remember the bit string problem, whatever that is the bit string, এটা যে যেরকমই হোক না কেন একটা valid bit string that is with no 2 consecutive zeros. At the end of this bit string, what were we doing? We were adding a 1 at the end of this bit string. Yeah. At the end of the bit string, we were adding a 1. Okay. We knew that we couldn't add a 0 in fear of what if the preceding value is 0, right? What if it's something like this? So here in this case, if you added a 0, then you'd have 2 consecutive zeros, which is not allowed. So the only bit that we could add is 1. So the only option we had to add when we were counting A is 1. So exactly 1-to-1 correspondence chilo. That is a bit string of length n-1. Bit string of length n-1 যেটা ছিল ওটার সাথে আমি just একটা single bit and only one option for that add করে I can get a count of the bit strings of length n. All right. However, here, how many options are there for you to add?
Miss
Miss, for
9.
how many, the number of zeros are even or not?
মিস এখানে তো 9টা মানে 9টা অপশন আছে অ্যাড করার মতো তো 9টা
Exactly.
কনসিডার
So
করতে হবে
see here, if we are considering the bit strings, sorry, the decimal digit strings of length n minus 1. If you're thinking about the decimal digit strings of length n minus 1, so notice that for AGA, একটা same decimal digit string, একটা same decimal digit string এর জন্য, for one decimal digit string of n minus 1 length, n minus 1 length এর একটা decimal digit string এর জন্য, how many decimal digit strings of length n do you get? একটার জন্য how many do you get? Think about that. If you add a 1 at the end, you get 1. All right. If you add a 2 at the end, you get another one. If you get a 3 at the end, you get another one, and so on. Yeah. So 1 থেকে 9 পর্যন্ত আমাদের যে অপশনগুলো আছে, 1 অ্যাড করলে for the same decimal digit string of length n minus 1, in order to convert that to a decimal digit string of length n, if we add 1, that is one result that we can get. If we add 2, that is another one. If we add 3, that is another one. That is for the same decimal digit string for one single decimal digit string of length n minus 1. একটার জন্য আমরা কয়টা decimal digit string পাচ্ছি of length n? Think about that. How many are we getting? For
9.
9. We are getting 9. Because we have 9 options here from 1 to n, 1 to 9, sorry. এখানের মধ্যে 1 to 9 যে কোনো একটা decimal digit add করা যায়. So we have 9 options here. একটা single n minus 1 length এর valid decimal digit string এর জন্য আমরা 9টা নতুন n length এর valid decimal digit string পাচ্ছি। এইভাবে যদি প্রত্যেকটার জন্য চিন্তা করো, for all of the n minus 1 length decimal digit strings, if you think about all of them that are here in this count, that are counted here, for each one of them, if you think about it, then what will this count be? Now, tell me, when we think about the count of all valid decimal digit strings of length n, which end with any digit from 1 to 9, now tell me, is it going to be the same as an minus 1?
No.
Think about the product rule and the sum rule and the basics of counting, the things that we discussed there. What will it be? It will be 9an minus 1, right? 9an minus 1. This can be done in one of 9 ways. So, একটার জন্য যদি আমরা 9টা পাই, so for each decimal digit string of length n minus 1, we get 9 decimal digit strings of length n. Okay? So প্রত্যেকটার জন্য যদি 9টা করে পাই, then an minus 1 এর সাথে we have to multiply 9. Right? Does it make sense, guys? Is everyone with me here?
Yes, ma'am.
Yes,
Makes
miss.
sense.
Okay, good. All right. However, tell me now, is this the total count? Is this the total count of the valid decimal digit strings, of length n? Is this the total count?
No, miss.
No, it's not. Why?
Miss, because odd number মানে invalid string ও থাকতে পারে
Invalid string কেমনে থাকবে? মানে invalid string তো আমরা কাউন্ট করব না। আমাদেরকে তো বলেছে valid strings কাউন্ট করতে। Valid strings as an even number of zeros আছে এরকম কাউন্ট করতে। So invalid string তো আমরা কাউন্ট করবই না। an এর যে কাউন্ট আছে ওখানে invalid string থাকবেই না।
মিস আমি যেটা বলতেছিলাম মিস যে odd numbers থাকলে ওটাকে even number করতে হবে বা সামথিং এরকম কোনো কিছু
না, odd number যদি থাকে তাহলে তো হচ্ছে গিয়ে we already don't count them at all. Odd number digit string তো we don't count them. I'm talking about the decimal digit strings of length n. Length n এর যে decimal digit string গুলো আছে, we have counted some of those here, all right? But we can say that this is not the entire count. Why is that? A length n এর যে decimal digit string গুলো আছে, What about the cases which end with 0? All right. What about the cases which end with 0? 0 তে end করে এরকম even number of zeros আছে, এরকম তো থাকতে পারে, right? You could just as well have a digit string of this format where you add a 0 and it still remains valid. এরকমও তো থাকতে পারে না যে 0 add করেছি and it's still valid. 0 add করার পরেও there are even number of zeros there. All right? Is it not possible যে 0 add করার পরে we still get even number of zeros and it still remains valid? It's possible. Here we handle the case using an-1, which contains the count of all bit strings, sorry, all decimal digit strings which are valid. Fine. an-1 কে utilize করেছি, so an-1 এর মধ্যে তো শুধুমাত্র valid string গুলো আছে, so that's why valid string যেহেতু we added এই যে any digits from 1 to 9. But what about those decimal digit strings of length n, those decimal digit strings which end with a 0, and is still valid? All right. I mean, এখানের মধ্যে তো মানে হচ্ছে গিয়ে 0 তে end করে না, basically 0. We are counting here all those decimal digit strings which do not end with 0, right? Here you have in this count you have all those decimal digit strings of length n which do not end with 0. What about then those decimal digit strings of length n which do end with 0? What about those? Have we counted those?
No, miss.
So we have to count those as well, all right? And only then we'll get the total count. Okay. So for that, we'll utilize some of the things that one of you guys were mentioning. I think it was Fahim. We will utilize the idea of decimal digit strings which are not valid. Okay. So first of all, think about a decimal digit string of length n-1, right? A decimal digit string of length n-1, a decimal digit string of length n-1 which is not valid. That is, the number of zeros in this decimal digit string is not even, it's odd. If there are odd number of zeros in a decimal digit string of length n-1, আমাদের কাছে যদি এরকম কোনো decimal digit string থাকে which is of length n-1, and there are odd number of zeros there, and then if we add a 0 at the end, what happens to the length? First of all, guys, what happens to the length?
n
Becomes n. And what happens to whether this decimal digit string is valid or not? Before adding 0, it was not valid. But what will happen now? Will it be valid?
yes miss.
How so? Because previously we had odd number of zeros. এখন একটা 0 যদি add করে, it becomes even. So now it's valid. We will, in order to count those decimal digit strings of length n which end with 0 and are valid, we will utilize this approach. We will use the invalid decimal digit strings of length n-1 and add a 0 to them, and hence we get the length n, and the decimal digit string becomes valid, and now we can count them. All right, we'll use that. Okay.
Miss,
So-
ওইটাই বলতে গেছিলাম মিস, but I
Yeah,
think
but yeah, I mean,
Yeah, I-
see, that is the process, but that is not the reason. So এখানে যে এই যে এইখানের মধ্যে why this is not the total count, that is not the reason. The simple reason for that is simply we haven't counted those decimal digit strings of length n which end with 0. But how will we do that? Is the process is along the lines of what you were saying. যে একটা invalid decimal digit string নিব of length n-1, ওটার সাথে যদি আমি একটা 0 এখন add করি, now the length becomes n and also it becomes valid. So we will use that idea along the lines of what you discussed. Exactly that. Now, in order to do this, first we have to get the count of those decimal digit strings which are invalid. Remember, we can only use an-1. We are only allowed to assume that we know the value of an-1, but an-1 is the count of what? The valid decimal digit strings of length n-1, valid ones. সো এই যে আমরা যে ইনভ্যালিডটা ইউজ করতে চাচ্ছি n-1 লেংথে যে ইনভ্যালিড n-1 লেংথে যে আমি ইনভ্যালিড ডেসিমাল ডিজিট স্ট্রিংটা ইউজ করতে চাচ্ছি, that one, this count, right? This count, where will we get that? এই জিনিসটা, the count of the decimal digit strings of length n-1 which are invalid, because here in an-1 all of them are valid. an-1 এ কিন্তু শুধুমাত্র valid গুলা count করা হয়েছে as per the rules in the question. Now we need the count of those which are invalid. In order to do that, first what we will do is we will try to count the total number of decimal digit strings of length n. A even number of 0, odd number of 0, if we forget that for a moment, a condition tar karone eto jhamela, a condition ta if we forget that for a moment, in that case, what is the count of the total number of decimal digit strings of length n? Again, think about it, sum rule, product rule, we discussed at the start of the counting chapter. Think about those. How would we do that?
It's 10 to the power n.
10 to the power of n. Okay, that's a possibility. Now, remember that we are converting the n-1 length decimal digit strings which are invalid, all right? n-1 decimal digit strings which are invalid into n length decimal digit strings which end with 0 and are valid. Okay. Right. So first, what do we need? We need the count of these n-1 length decimal digit strings. We need the count of these. So this time, first we need to count all decimal digit strings of length n-1. Okay. All decimal digit strings of length n-1. That is what we need to count. So in that case, what would this number be? n-1 length there, decimal digit string, the total count of all decimal digit strings of length n-1. That is the count we need, right? ওই count আমার লাগবে, ওইটা থেকে আমরা হচ্ছে গিয়ে we can find the decimal digit strings of length n which are valid. First, we need to count the decimal digit strings of length n-1. Simply that. Valid, invalid, on a number of zeros, we're not thinking about that. Simply all decimal digit strings of length n-1. We are going to count that. All right. I have a point. You'll see that. So what is the count of that number? Can you guys tell me? First of all, 10 to the power of n is what? 10 to the power of n is the count of those decimal digit strings which are of length n. N-lengthed decimal digit strings, all decimal digit strings of length n, regardless of even number of zeros, odd number of zeros, forgetting that, all decimal digit strings of length n, the count of that is 10 to the power of n. All right. So in case of n-1, what will it be?
10 to the power n-1.
10 to the power of n-1, that's correct. And why is that? Why is it 10 to the power of n-1?
Because we are considering n-1 length.
n-1 length, fine. Then why 10? Why is the base 10?
Yes, that's what I'm confused about. I just said it and I can't figure it out.
We're taking both invalid and valid.
Sorry?
We're taking both invalid and valid
হ্যাঁ,
in
বেসিক্যালি
consideration.
আমরা ওই জিরো নিয়ে চিন্তাই করছি না, আমরা জিরো বাদ দিয়ে চিন্তা করছি যে n-1 লেংথের একটা ডেসিমাল ডিজিট স্ট্রিং যদি কনস্ট্রাক্ট করি, how many possibilities are there? That's how many, what is the total count of possible decimal digit strings of length n-1? Simply, as simple as that, without valid, invalid, whatever. So for that, the count is 10 to the power of n-1. Why is that? এই জিনিসগুলো তো, remember, we studied these things in counting, the basics of counting. We did these things. So n-1 length যদি একটা decimal digit string আমাকে বানাতে হয়, how many positions are there to be filled up? কয়টা decimal digit লাগবে? How many positions are there n-1 length হলে?
10 power n-1.
পজিশন কয়টা? পজিশনের ক্ষেত্রে 10 to the power of কেমনে আসতেছে? তোমার লেংথ n-1, একটা n-1 লেংথের অ্যারের মধ্যে কয়টা পজিশন আছে? কয়টা, একটা অ্যারে যদি চিন্তা করো, an array of length n-1, How many positions are there in that array?
n-1
n-1 আমাকে কেন জিজ্ঞেস করছো? You guys figure it out. একটা 10 যদি decimal digit string, একটা string চিন্তা করো, একটা string এর length যদি n-1 হয়, তাহলে ওই string এর মধ্যে কয়টা পজিশন থাকবে, কয়টা digit বা কয়টা literal whatever it is, কয়টা থাকবে? Let's say for example Fahim's first name, all right, Fahim. What is the length there of that string? Fahim 5. মানে কি এখানে কয়টা মানে পজিশন আছে? 5টা পজিশন আছে, right? 5 positions taken up by these 5 specific letters, right?
Yes, miss.
So এই বেসিক জিনিসগুলো oh my god, basics of counting সব খেয়ে বসে আছে. Remember that's still in the syllabus of the final exam, right? So when we are trying to construct a bit string, sorry, a decimal digit string, when we are trying to construct a decimal digit string of length n-1, basically এই decimal digit string টাতে এই যেটার length n-1 এখানে কয়টা decimal থাকবে, কয়টা digit থাকবে, টোটাল কয়টা digit থাকবে?
n-1
n-1 number of digits থাকবে. The length is n-1, তার মানে কি n-1 positions to be filled up with n-1 digits, all right? So there are n-1 positions here. Think about the first position. For the first positions, how many options do you have to fill up the first position? This string is made up of decimal digits, right? So first position data, how many options do you have for the first position?
n-1 miss আমি আর answer করব না
No, it's fine. No. I mean, if you guys don't discuss this ideas, তোমরা নিজেরা try না করলে how will you be able to, মানে এই জন্য তো প্রবলেমটা হয়, মানে you have to give it a try yourself. Otherwise, how will you solve the problems when in the exam, when you have to rely completely on your own, all right? So n-1, first of all, n-1 length এর যদি একটা decimal digit string এর কথা চিন্তা করি, মানে we have to think about যে ওই string এ কয়টা decimal digit আছে, that is ওই string এ কয়টা position আছে to be filled up. Counting এর problem গুলো চিন্তা করো, go to the basics of counting. How do we count such problems? এই ধরনের প্রবলেমের জন্য আমরা কিভাবে কাউন্ট করি? মানে রিমেম্বার দ্যাট
পজিশনে মিস আমার n-1 টা অপশনস থাকবে, সেকেন্ডটা n-2
how do you have n-1 options for the first position? Length is n-1. Length n-1 হলো অপশন n-1 কেমনে হলো? Length n-1 তুমি চিন্তা করে দেখো, length n-1 কথাটার মানে কি? What is the meaning of this term? Length n-1 মানে কি? একটা স্ট্রিং এর লেংথ, তোমার ধরো ফার্স্ট নেমের লেংথ হচ্ছে গিয়ে 5. What does that mean? ধরো we want to come up with a name, any name, all right? Any name from the alphabets, all right? Alphabeটের যে লিস্টগুলো আছে, আপার কেস লোয়ার কেস চিন্তা করছি না, এই যতগুলো alphabet, 6 alphabet, right? 26টা লেটার থেকে, 26টা alphabet থেকে we want to make up a name, all right? So ওই নামটার মধ্যে if we say that the length of the name will be 5, length of the name is 5 মানে কি? What does that mean? Tell me that.
String of length 5.
String of length 5, exactly. So how many positions will be there in that string? 5 positions, right? So
Yes,
for
yes.
each of these positions, what do? We see how many options there are to fill up these positions. Prothom position to fill up the first position, how many options do you have? You can use any alphabet. How many alphabets are there? 26টা alphabet আছে, 26টা alphabet থেকে যে কোনো একটা যদি ইউজ করতে পারো, then how many options do you have to fill up the first position? 26. Second এর জন্য how many options do you have?
26.
So on, প্রত্যেকটা for each of the 5 positions you have 26 alphabets, 26 options to fill up those positions. So how many names could you come up with if you could use any combination and any alphabet from the list of alphabets?
26 to the
26 power 9. Power n. Sorry.
power 5 আর কি
Length যদি 5 হয় তাহলে 26 to the power of 5. So you see যে এই যখন আমরা এই চিন্তা করছি যে filling up the positions, filling up the first position, how many options do you have? Is it 5? Is it equal to the length?
no miss
No. So you see the point, here মানে যদি ধরো আমার যদি n-1 লেংথের একটা ডেসিমাল ডিজিট স্ট্রিং হয় তার মানে কি I have n-1 positions, all right? n-1 positions to fill up, okay? So basically position 1, then position 2, then position 3. Position 1, position 2, position 3, and then position 4 and position 5 and so on until the n-1th position, okay? Position 1, 2, 3, 4, 5 until the n-1th position. So position এর কথা চিন্তা করছি এখানে length n-1 মানে কি length n-1 একটা string এর length n-1 মানে কি ওই string এর মধ্যে n-1 characters আছে, all right? n-1 characters আছে. Here in this problem we are talking about decimal digit strings, that is strings made up of only decimal digits, okay? So a string which contains n-1 decimal digits, that is the length is n-1, will have n-1 number of total positions. এখন we have to see how to fill up each one of these positions. প্রথম পজিশনটা fill up করার জন্য again how many options do we have?
মিস 10টা মিস এবার বুঝছি
Why do we have 10 options?
বিকজ ডেসিমাল আমার টোটাল 10টাই আছে মিস
Exactly 0 থেকে 9 আমার 10টা ডেসিমাল আছে 10টা ডেসিমাল ডিজিট আছে প্রথম পজিশনটা fill up করার জন্য we have 10 options to choose from second position fill up করার জন্য again 10 options to choose from third again 10 and so on until what until the last position the n-1th position n-1th position যেটার জন্য again 10 multiplied with 10 multiplied with 10 and so on until the n-1th position that gives you 10 to the power of n-1 all right counting a lecture গিয়ে স্লাইড গুলো আবার দেখো okay final exam কিন্তু counting still is there in the syllabus so remember that but now is it clear to everyone that the total count of decimal digit strings of length n-1 regardless of valid invalid whatever just the total count of all decimal digit strings of length n-1 is going to be 10 to the power of n-1. How we got this number? Is it clear to everyone?
Yes, ma'am.
Okay, thank you. Just the basics of counting. Okay, so now that we have this count, think about it. এখানে 10 to the power of n-1 is the count of the total number of all decimal digit strings of length n-1. We have that here. And here what do we have? This is the count of all decimal digit strings of length n-1 which are valid. We have here an-1 এর মধ্যে the count of all decimal digit strings of length n-1 which are valid. আর এখানের মধ্যে valid invalid regardless সবগুলোই আছে. All of them are here in this count 10 to the power of n-1 এর মধ্যে all of them are here and here in an-1 we have only the valid ones. What do we want? We want the count of decimal digit strings of length n-1 which are invalid. Can you tell me, is it possible to get that from this count and this count? আমাদের কাছে 10 to the power of n-1 this 10 to the power of n-1 what is this value? This is the count of all decimal digit strings, all of them. All right, and an-1 is what? Is the count of only the valid ones. শুধুমাত্র valid ones are there in an-1. আমরা চাচ্ছি কোন কাউন্টটা? Which count do we want? We want the invalid ones, the invalid decimal digit strings of length n-1. We want that. Invalid টা চাচ্ছি, আমাদের কাছে টোটালটা আছে, validটা আছে. How can we get the invalid? How can we get the count of decimal digit strings of length n-1 which are invalid? How can we get that?
মিস 0 অড হতে হবে
হ্যাঁ 0 odd হতে হবে ওই জন্যই তো invalid. Yeah, fine, invalid এর মধ্যে 0 odd হতে হবে. We have established that. But how will we get this count? এই যে এই কাউন্টটা তো আমাদের লাগবে তাই না যে টোটাল n-1 লেংথ এর কতগুলো invalid decimal digit string আছে এটা তো আমাদের লাগবে কারণ invalid গুলোকেই তো আমি 0 অ্যাড করে ভ্যালিড করছি তাই না
ইয়েস মিস
invalid প্রত্যেকটা invalid decimal digit string of length n-1 ওই প্রত্যেকটাকে আমি 0 অ্যাড করে we are converting to valid. So in order to get the count of the total number of decimal digit strings of length n which end with 0. In order to get that count, what do we need? We need the count of total number of decimal digit strings of length n minus 1 which are invalid. এই invalid গুলাকেই তো আমরা convert করছি, so invalid এর count টা লাগবে. So I'm telling you again, so far what do we have? 10 to the power of 10 to the power of n minus 1. What is this? A 10 to the power of n minus 1 is the count of what? Tell me. What is the count? What is this?
Count of all valid and invalid.
All of them basically. All right, all valid, invalid, all of them, all of the decimal digit strings of length n minus 1. What is this? An minus 1 key. What is an minus 1?
All
Invalid.
valid.
Valid.
Sorry? The count of what? What now?
Miss all valid strings.
All valid decimal digit strings. The count of all valid decimal digit strings is an minus 1. All right? So how will we get the invalid? The count of the invalid decimal digit strings.
Miss minus করে দিব।
Action.
It's just minus a and minus 1.
Okay? But you also have to tell me why. Why minus a and minus 1?
Means because first 10 to the power n minus 1 তোমার like includes all valid and invalid আর আমি এখান থেকে
Exactly.
valid টা minus করে দিচ্ছি so invalid টা পাবো।
Exactly. As simple as that. Total count আছে, total count থেকে আমি valid এর countটা যদি deduct করি তাহলে what do I get? The count of the invalid ones. And why do I need this count? এই count আমার কেন লাগছে? Because when we are counting the decimal digit strings of length n which end with 0, when we are trying to do that, how are we doing that? First, we are taking the decimal digit strings of length n minus 1 which are invalid. n minus 1 length decimal digit strings যেগুলো invalid ওগুলোকে নিচ্ছি, ওগুলোর সাথে লাস্টে 0 অ্যাড করছি, so length n হয়ে যাচ্ছে and also it becomes valid. All right? So this will be the count of the total number of decimal digit strings of length n which end with 0. So each and every one of the n minus 1 length invalid strings, each and every one of the invalid strings of length n minus 1, প্রত্যেকটা n minus 1 length invalid string যেগুলা ওগুলোর লাস্টে যদি আমি 0 অ্যাড করি, each one of them is converted to a valid n length digit string of which ends with 0. Okay? So প্রত্যেকটাকে যদি convert করা possible হয়, then the count of the decimal digit strings of length n which end with 0 is going to be equal to what? This count. All right? AJ counting the decimal digit strings of length n which end with 0. This count is going to be equal to what? ফার্স্টে চিন্তা করো কিভাবে করছি কিভাবে আমরা একটা ভ্যালিড n length digit decimal digit string, একটা ভ্যালিড n length decimal digit string which ends with 0, এই ফরম্যাটে কনভার্ট করছি কিভাবে? আমরা প্রত্যেকটা n minus 1 length এর invalid string কে নিচ্ছি. Every single one of those invalid string is taken and প্রত্যেকটা invalid এর সাথে একটা 0 অ্যাড করে দিচ্ছি, right? So every single one of these invalid n minus 1 length decimal digit string is converted to a valid n length decimal digit string that ends with 0. So এই entire value যদি বের করতে চাই, the count of the decimal digit strings of length n which end with 0, how can we do that? Isn't it going to be the same? Isn't it going to be the same as the invalid decimal digit strings of length n minus 1?
Yes, ma'am.
Yes, ma'am. কি বুঝে বলতেছো? Do you understand?
Yes, ma'am. We
Why-
are converting the invalid ones into valid ones, right? After adding
Yeah.
0.
Exactly.
So yeah, the count will be
Every
same.
single one. Exactly. Every single one of them are getting converted to 0. Every single one of them. So এখানের মধ্যে যে কাউন্টটা আছে, n minus 1 invalid string এর মধ্যে যে কাউন্টটা আছে, ওই কাউন্টটা আর and this count of n length decimal digit string which end with 0 is going to be the same. আমরা যদি এই যে n length decimal digit string which end with 0, if we represent that using b, if b represents that, if b represents such the count, b represents the count of decimal digit strings of length n which end with 0, what will this be equal to? B will be equal to what?
10 to the power n minus 1 minus a minus n minus 1.
Exactly. That's correct. But tell me now, here for example, a counter সাথে a n minus 1 যে counter আছে, right? A n minus 1 যে counter আছে, ওটার সাথে we multiplied 9. Why did we not do the same thing here? এটার সাথে for example এই যে এখানে এরকম 9 কেন multiply করি না? Why did we not do that? Why did we not do something like that? Can you tell me?
There's only one possibility. We're adding only zeros.
Very good. প্রত্যেকটা n minus 1 for every single n minus 1 invalid string, you get how many valid n strings? Just একটাই. Because there's only one option. শুধুমাত্র 0 add করছো. So একটা single n minus 1 length invalid string যদি চিন্তা করো, ওটাকে কনভার্ট করে তুমি একটাই n length string পাচ্ছ। Previously একটা single n minus 1 length decimal digit string থেকে, একটা single n minus 1 length decimal digit string থেকে আমরা 9টা n length decimal digit string পাচ্ছিলাম। একটা থেকে 9টা পাচ্ছিলাম। Because number of options here to add were from 1 to 9. 9 options. Here we are adding only 0. So একটা এই n minus 1 length decimal digit string থেকে you are getting only one single n length decimal digit string which is valid. All right? So that's why the count will be the same. Okay? And this count is going to be the same as the total count of decimal digit strings of length n minus 1. Because a n minus 1 প্রত্যেকটা string কেই তো convert করছি। So a n minus 1 এর যে counter, the count of those strings of length n minus 1 which are invalid is going to be the same as the count of the strings of length n which are valid and end with 0. Okay? Is this clear so far? A and B. Is this clear so far, guys?
Yes.
All right. In that case, finally, আমাদের job কি ছিল? What was our job? Our job was to count an. All right? Our job was to count an. What will an be equal to? Total count of valid decimal digit strings of length n. What will that be?
A plus b.
A plus b, exactly. So we will add a and b, and that will be our count. Right? That is our count. Right? And also, what do we have here? 9an minus 1 minus an minus 1. So what can we say about this? 9an minus 1, 8. Exactly.
n minus 1.
Simply 8an minus 1 plus 10 to the power of n minus 1. Right? So this is our recurrence relation. This is our recurrence relation to solve this counting problem. But are we done yet? Is that all that we have to define to solve this counting problem? এই যে আমরা যে assume করছি যে আমরা an minus 1, we know an minus 1, কিসের basis assume করছি? যে we know this an minus 1. On what basis are we, on what grounds are we assuming that we know this value? আর ফিবোনাচি সিকোয়েন্সের যে recurrence রিলেশনটা আছে, ওই যে fn is equal to fn minus 1 plus fn minus 2. Is that the one single sole thing that defines the entire sequence? ওই একটা জাস্ট ওই রিলেশনের বেসিসে কি পুরো সিকোয়েন্সটা পাবা? Do you not need any other information?
Yes, f0 আর f1 লাগবে।
f0 and f1 লাগে, exactly. Why? Because তুমি দুটা preceding value ইউজ করছো, ওর জন্য তোমার initial condition মানে base condition for the lowest, the two lowest values of n, you have to find out what the value is. So initial condition define করতে হচ্ছিল। এখানে এই যে এই রিকারেন্স রিলেশনটা যে সুন্দর মতো লিখলাম, assuming that we know an minus 1. এই assumptionটা কোত্থেকে আসছে? What is the basis of this assumption? On what grounds are we allowed to make this assumption? That we know the initial condition. We know the initial condition. We know the base case, the lowest possible value of n. Lowest length কত হতে পারে একটা decimal digit string এর? What is the least possible length of a decimal digit string? 1. Right? n represents the length of the decimal digit string, right? N represents the number of decimal digits in the string. What is the lowest number of decimal digits that you can have in the string? What is the lowest length that you could have? Is 1. All right? So initial condition ki define korte hobe na, recurrence relation ekta mane key part ki, not just the recurrence relation itself. Along with that, you have to define the initial condition, remember? So we have to define A1. What is A1? A1 ছাড়া তো এই রিকারেন্স শুধুমাত্র A1 ছাড়া শুধুমাত্র এই রিকারেন্স রিলেশন দিয়ে যদি বলো যে যাও এখন বের করো, how will you find that? an-1 তো জানো না, you don't know the value of an-1. We assumed we know an-1, but based on what grounds? On the grounds that you define the initial condition. ওটা ছাড়া তো an-1 বের করা পসিবল না, an-1 বের করা পসিবল না হলে an বের করা পসিবল না. So you have to define the initial condition. All right? So here, how many preceding values are we using, guys? an বের করার জন্য কয়টা প্রিসিডিং ভ্যালু ইউজ করছি আমরা?
10, I guess.
Is 10 মানে 10 how 10? Tell me that. How 10?
I mean, I'm not sure. I'm kind of confused.
এই যে ফিবোনাচি সিকোয়েন্স যেটা আছে, in this sequence, how many preceding values are you using?
We had 2, 0 and 1.
2. No. Those are the initial conditions. Those are the base cases.
Yeah.
এই যে fn যে বের করছো based on what value? fn-1 and fn-2.
Oh, yes.
Preceding কথাটার মানে কি? n এর আগের ভ্যালু গুলো, right? Immediately আগে যেগুলা. You are using 2 preceding values. The values that precede fn, you're using those to get this recurrence relation, all right? A recurrence relation it uses to get fn, to get the value of fn, you're using these 2 preceding values. And why can we use this? Because আমরা initial condition গুলো define করেছি. A initial condition f0 equals to 0, f1 is equal to 1. A base case or initial condition যদি আমাদের কাছে না থাকতো, without this, would you be able to use this recurrence relation to find fn? No. Because you have this, along with this recurrence relation, you can find fn. এইটা থাকার কারণে আমরা কি বলতে পারছি যে f0 আর f1 জানি, for n greater than equal to 2 we have this recurrence relation. So f0 আর f1 যদি জানি, what will be f2? f0 plus f1. So from there you find f2. 0 plus 1, 1. Now that you know f2, from f1 and f2 what can you find? You can find f3. Next, if you want to find f4, you need f3 and f2, but we already found out f3 and f2. So you see, the recurrence relation gives us the value fine as long as we give the starting point. A starting point আমাকে ধরে দিতে হবে, right? A starting point ছাড়া তো তুমি কোনো পয়েন্টে যেতে পারবে না. Without these initial conditions, how would you be able to find out the value of fn-2, which you need to find out fn? Do you understand what I'm saying? So same way তে এখানে বলো again, which one? How many preceding values are you using in this recurrence relation? This recurrence relation solves our counting problem, right? This is the representation of the count of an, of the value that we have in an. How many preceding values are we using to get the value of an? কয়টা ইউজ করছি? একটা ইউজ করছি. So এই একটার জন্য আমার কয়টা ইনিশিয়াল কন্ডিশন লাগবে? একটাই লাগবে. Fibonacci sequence, remember the Fibonacci sequence. এখানের মধ্যে we were using 2 preceding values. We have 2 initial conditions here, all right? এরপরে যে আরেকটা recursive definition আছে একটা সিকোয়েন্সের, এই যে an equals to n-1, an plus n plus -2 plus n-3. কয়টা preceding value ইউজ করছি এখানে এই recurrence relationটাতে? In this recurrence relation, how many are we using? 3. দেখো initial condition কয়টা? 3টা. এই 3টা initial condition ছাড়া this recurrence relation alone is not valid. এই 3টা initial condition ছাড়া এই recurrence relation ইউজ করে তুমি n কিভাবে বের করবা? এই 3টা তো লাগবেই. Because this recurrence relation is for all n greater than equal to 4. All right. So because we know a1, a2, a3, a1, a2, a3, because we know these things, because we know a1 and a2 and a3, we know the value of these. From this, we can find out what? a4. a4 বের করা যাবে from these 3 values. Using this recurrence relation, we can find a4 because we have a1, a2, a3 available for us. And for using a4 and A2 and A3, A2, A3, A4 use করে next we can find out A5, এরপরে A6, এরপরে A7. So that's how we can make the progression. But base case গুলো তো জানতে হবে, তাই না? So same way তে এখানের মধ্যেও fine, you will get an from an minus 1. Fine, an minus 1 থেকে you can get the value of an. But you have to define the initial condition as well, right? যদি ইনিশিয়াল কন্ডিশনটা না জানো, a1 এর ভ্যালু না জানো, an পর্যন্ত কিভাবে যাবা? If you know the value of a1 এর ভ্যালু এখানে বসায়, what can you find out? The value of a2. Once you find out the value of a2 এর ভ্যালু এখানে বসায়, what can you next derive? The value of a3. And from a3 you can find out a4, from a4 you can find out a5. এভাবে করে you can go on until an. Okay, so we have to define a1. What will be a1 now? Tell me that. A1 মানে decimal digit string টার length কত? What is the length of the decimal digit string for A1? A1 এর মধ্যে the count of A1, what is A1? A1 is the count of
One.
decimal digit strings of length what? 1, exactly. A1 is the total count of the decimal digit strings of length 1 which are valid. One length are all decimal digit strings which are valid is the count here, okay? So what will that number be?
1 to 9, any one of them?
Any one of them could be there in the decimal digit string. Good, yeah. Length is 1. Length যদি 1 হয়ে থাকে, then any one of the decimal digits from 1 to 9 could be there. 1 use করে একটা decimal digit string বানাতে পারো, 2 use করে বানাতে পারো, 3 use করে বানাতে পারো, and so on until 9. Why not 0 though? Why not 0 to n? 0 is a decimal digit string as well. Why not 0 then? Sorry?
It won't be it would be invalid.
Very good. Because 0, যদি A1, in order to count A1, if you count the decimal digit string of length 1, which is just 0, in that case, how many zeros are there in that string? Only 1. That's odd. So, odd number of zeros হচ্ছে. Okay? So, we cannot count that. However, 1 থেকে 9, if you make up the decimal digit string using any one of the digits from 1 to 9, how many zeros are there? Let's say a decimal digit string, let's say a decimal digit string of length 1. Length 1 একটা decimal digit string, আমি বললাম এটা 1. How many zeros are there?
No zeros.
No zeros. That is 0 number of zeros. And what is 0? An even number. So you have even number of zeros there basically, all right? No zero মানে কি? 0 number of zeros, and that is even number of zeros. So if you use if you create a decimal digit string, if you create a decimal digit string of length 1 using any one of these digits, 1 থেকে n পর্যন্ত, any one of these digits, then the total number of zeros in those will be even. No zeros, that is 0 number of zeros and even number of zeros, hence. So all of those are valid. And how many such decimal digit strings could you have? How many such decimal digit strings could you have? One length এর কয়টা এরকম decimal digit string form করা possible? 9. Exactly, 9. 1 use করে একটা, 2 use করে আরেকটা, 3 use করে আরেকটা, 4 use করে আরেকটা. So 1 itself is a decimal digit string of length 1. 2 itself is a decimal digit string of length 1. And so on until 9. So 9টা option আছে, so the value is 9. So A1 will be equal to 9, all right? Yeah. So that is the recurrence relation with the initial condition, okay? So with this, we conclude the topic of solving counting problems using recurrence relation. So you would get a counting problem of this format, or the bit string one, or the example preceding that one, and ওই প্রবলেমটা সলভ করতে হবে রিকারেন্স রিলেশন ইউজ করে। তাহলে কিভাবে করতে হবে? In order to get an, you have to think about preceding value থেকে পাওয়া যায় কিনা। preceding value মানে কি? an এর immediate আগের value কোনটা? What is the value that what is the count that you have immediately before an?
Sorry, miss, could you repeat?
আমি বলতে চাচ্ছি যে এই ধরনের প্রবলেম বেসিক্যালি রিকারেন্স রিলেশন ইউজ করে যদি সলভ করতে বলা হয়, how would you solve that? Alright, এই ধরনের প্রবলেম, this problem or the bit string problem, how did we solve that? Right? আমরা কি করি, an বের করতে হবে, right? an বা এই ধরনের যে কোনো একটা নাম্বার বের করতে হবে. What did we do? Every time we try to see, is it possible to get that value using the preceding counts, alright? Preceding counts. an এই যে এই কাউন্টের ইমিডিয়েট আগের কাউন্টার, what is that going to be?
N minus 1.
an minus 1. Similarly, for some sequence, if you're using some sequence, কোন একটা সিকোয়েন্স বা সিরিজ ইউজ করলে an এই ভ্যালুটা যদি বের করতে চাই, কোন একটা nth ইন্ডেক্সে একটা nth পজিশনে an এর ভ্যালু বের করতে চাচ্ছি, what will we try to do? We will first try to see immediately আগের ইন্ডেক্সে যে ভ্যালুটা আছে an minus 1, ওটা থেকে বের করা পসিবল কিনা, অলরাইট? ওটা থেকে কি কি বের করা পসিবল? Just like this one here. In this case, the length, n represents the length. In case of the Fibonacci sequence and the other sequence that we studied in induction, n represented the index. In this case, n represents the length. The bit string problem and this decimal digit string problem, both of them, n represents the length. So n might represent length or represent the index, any one of those. Whichever that is, an কে আমাদের বের করতে হবে। আর an যদি বের করতে হয় কি করব আমরা? রিকারেন্স রিলেশন ইউজ করে যদি সলভ করতে চাই, আমরা ট্রাই করব দেখতে যে an-1 থেকে বের করা পসিবল কিনা। As you can see here, this problem can be solved just by using an-1. an can be found out just using an-1. Here, 8 an-1 plus 10 to the power of n-1. Just if you know an-1, একটা single n-1 থেকে পুরোটা বের করা পসিবল। If, however, you see that শুধুমাত্র an-1 দিয়ে বের করা পসিবল হচ্ছে না, as we saw in this case. In this case, as we saw, using only an-1, it wasn't possible to get the entire value of an. Then we moved into what? Moved into using an-2. তার আগেরটা an-1 শুধুমাত্র একা an-1, if we cannot derive the value of an only from an-1, what will we do? We will put it back. এর আগেরটাতে যাব, an-2 তে দেখব an-2 ইউটিলাইজ করা পসিবল কিনা। In this example, for example, an can be derived using an-1 and an-2, both of them. If an-2 is not enough, in that case, what do? You push further back. You see an-3 use kore possible kina. All right? So whenever you have to solve a counting problem using recurrence relation, first you have to see whatever you have to find out, whatever you have to count. In this case, for example, we have to count an, whatever that is. In order to count an, we'll see, is it possible to count this using an-1, assuming that we know an-1. If you can do that, in this case, for example, শুধুমাত্র an-1 দিয়ে count করা possible, an-1 থেকে n derive করা possible. If you know that, then that is your recurrence relation. And since you're using one preceding value, lowest base case যেটা initial condition, একটা initial condition তোমাকে define করে দিতে হবে। In the previous case, for example, an-1 was not sufficient, so we had to push back and we used an-2 as well. Okay, so in order to derive the value of an, we had to use both an-1 and an-2. Okay, so that was the recurrence relation. And since we are using two preceding values, initial condition দেখো, we defined a1 and a2, two initial conditions. n এর দুটা lowest value জন্য we defined what a would be, what the count would be. Okay, n এর দুটা lowest value জন্য, because we use two preceding conditions here. And n, obviously, for this recurrence relation, n obviously will be greater than or equal to 3. Okay, n will obviously, for this one, for example, for this recurrence relation, n will be what? For this recurrence relation, greater than or equal to 2. All right. Do we all understand now? Do we have an idea of counting problem, how to solve counting problem using recurrence relation?
Yes, ma'am.
So if you were given a certain, any random counting problem and you were asked to solve it using recurrence relation, would you maybe give it a try, or would you say that, okay, it's possible to solve, for you to solve that?
This is possible, but পারবো না দেখবে।
Possible hole, you're saying contradictory things, aren't you? You're saying
Yes.
possible and impossible in the same sentence. If it's possible, how is it impossible? If you know, if you understand the process, then it's definitely possible. এখানের মধ্যে so far আমরা যা যা করেছি খুব impossible কোনো কিছু করি নাই, very simple things, all right? mean an minus 1 থেকে an derive করছি, n minus 2 থেকে an derive করছি, alright? So I'll post either an assignment or a problem set based on recurrence relation as well. And it's very important that you understand how to solve counting problems using recurrence relation. Why? ওই যে last class যে বলেছিলাম recursive algorithm লিখতে পারাটা, that is a very important skill that a programmer should have. Being able to solve problems using recursive algorithm. Obviously recursive algorithm ছাড়া অন্যান্য solution থাকতে পারে, অন্যান্য way থাকতে পারে solve করার, but you will see that recursive algorithm usually it's the most efficient one. Also, some problems do exist which have only and only a recursive solution, all right? So you must know, understand how to solve counting problems using recurrence relations. Recurrence relation use করে কেমনে counting problem solve করতে হয় এই জিনিসটা বুঝাটা is absolutely crucial for you guys, all right? So if you have any question so far at this point for any of the examples, ask me and I'll gladly go over it again, all right? And if you don't have any questions, I'll upload the lecture slides since we're done today. Go over them and see whether you understand or not. If you don't understand, ask me again later. And if you do, try solving problems using counting problems using recurrence relation. It's very important that you understand that, all right? Okay. Next, what we will do is we will try to solve the recurrence relations themselves. For example, what I mean by that is, see here, so one of the students from the other section in the last session pointed out that here we are using this recursive definition to define the Fibonacci sequence. Here we are using a recurrence relation in the original definition. But this is another equation that also defines the Fibonacci sequence. So the question was, is it not more efficient or is it not easier to use this equation? Because this equation relies on what? Only on the index n, all right? So এই ধরনের equation যেগুলা, this equation, the second equation of fn, which solves the same sequence, same Fibonacci sequence, is this equation dependent on preceding values, guys?
No, miss.
No. All you have to do is know the value of n, the index. And index represent koruk ba length represent koruk, ota janle you can find the value, all right? But a simple equation ta, what is the source of this equation? That is the question. A equation ta kotheke asche? We will see that. How to solve recurrence relations to get an equation of this format. How to do that? That is what we will see next, okay? So first of all of the recurrence relations that we have seen so far, these are linear recurrence relations, all right? Linear recurrence relation. We were asked to find the value of n, to count the value of n, all right, using recurrence relation, and every single recurrence relation that you've seen were of this format. You had a constant coefficient and then you were using preceding value n minus 1, n minus 2 if you need that, n minus 3 if you need that, and so on until n minus k for some value, for some integer k, all right? So all of them fall under the same category, linear homogeneous recurrence relation of degree k, all right? For example, this Fibonacci sequence, all right, what is the degree of this relation? You're deriving the value of fn from what? Fn minus 1, Fn minus 2. What are the coefficients, first of all, for each of these terms? Fn minus 1, a constant coefficient is 1. Fn minus 2, a constant coefficient is 1 as well. What is the degree of this linear homogeneous recurrence relation? The degree is 2, all right? So all of them can be represented using this specific format, okay? A format use kore shobguloke represent kora possible, all right? To a certain degree. For example, this an is equal to an minus 1 plus an minus 2. Here, the degree of this relation is 3, and the constant coefficients for each one of this is 1 and 1 respectively, all right? For this recurrence relation, what are the coefficients here? 3, minus 2, and 4. And what is the degree of this relation, guys? What is the degree of this relation? Degree key?
3.
3, exactly. It goes up until what? An minus 3. So degree is 3. Similarly, what is the degree of this recursive definition? Where did it go?
Ma'am, what do you mean by linear? Straight.
What is the degree of this recurrence relation?
3.
3, exactly. All right. So all such recurrence relations you see can be represented in this general format, where you derive n from the preceding values. যতটুকু পর্যন্ত লাগে আর কি. For example, for the bit string case, we needed only the first two. Sorry, the preceding two. Just immediate আগের দুটা লাগছিল. n-2 and n-1. n-1 and n-2 শুধুমাত্র আগের দুটা লাগছিল. So the degree is 2. So যতটুকু পর্যন্ত লাগে, that is your degree. So basically, until ck into n minus k. Yeah, ck is the constant coefficient for the an minus kth term, right? Where ck is not equal to 0. Right? And linear, what is the progression here? The progression is linear. Do you have square values here? No. Okay, that's what we mean by linear. If you were to plot this, then you'd get a linear curve, or basically a linear line. Yeah, that's what it means. So what we will see now is how to solve recurrence relations of degree 2. Amra আর complex কোনো কিছুতে যাব না, since we don't have that much time. We will only look at recurrence relations of degree 2 and how to solve recurrence relations of degree 2. All right. First of all, recurrence relations which are homogeneous and linear and are of degree 2 have a characteristic equation to solve them. The characteristic equation is r squared is equal to c1r plus c2. For a linear homogeneous recurrence relation of degree 2, the characteristic equation for that is r squared is equal to c1r plus c2. This is the equation that defines the recurrence relation. All right. This is the equation that we can use to solve the recurrence relation. The characteristic equation will always be this. Now we will use this theorem. A theorem take amra utilize korbo to solve the recurrence relation. Now what does the theorem say? The theorem says that if this characteristic equation has two distinct roots, a characteristic equation to r square is equal to c1r plus c2. এটাকে যদি solve করে if you get two roots, how will we solve them? The moment you know the recurrence relation, you know the value of c1, c2. For example, ekhane for this recurrence relation, what is the value of c1, c2, c3, guys? For this one, c1, c2, c3 value key. c1 is the first coefficient, it's 3. c2 is the second coefficient, what is that?
Minus 2.
c3 is the third coefficient, which is 4. All right. So similarly, for a recurrence relation with degree 2, you would have how many constant coefficients? Only 2. C1, C2. For the first sum term, it will be C1. For the second one, it will be C2. If we know C1 and C2, once we have the recurrence relation in our hands, if we will know C1, C2. C1, C2 জানার পরে, this equation can be solved for R, right? R এর value বের করে, if you see that there are two distinct values of R. R এর জন্য you get two distinct values. R square আছে কিন্তু. So obviously দুটা root থাকবে. If the roots are distinct, in that case, we can say that this recurrence relation, the one that we are trying to solve, that recurrence relation can be solved using this equation. All right. This recurrence relation, there is a one-to-one correspondence between this recurrence relation and this equation. An is equal to alpha 1 into r1 to the power of n plus alpha 2 into r2 to the power of n, where alpha 1, alpha 2 are constants and r1, r2 are the roots that you derived from the characteristic equation. And how can we solve this an? Alpha and r1 and alpha 2 are constants. We have to solve for alpha 1 and alpha 2. এই দুটার জন্য solve করতে হবে. How do we do that? By using the initial conditions. That is the significance of the initial conditions. Let's do an example to make it clear. We will use this theorem to solve this recurrence relation. All right. So this is the recurrence relation we have. These are the initial conditions. Okay. So here in this recurrence relation, can you guys tell me what is the value of C1 and C2?
If C1 is 1 and C2 is 2.
Exactly. A C1, C2 value 1 and 2. যদি আমি এই characteristic equation এ বসাই, what do we get?
R square equals to R plus 2.
Exactly. This is what we get. R square is equal to R plus 2. So if you have this equation, can we not solve for R?
Yes, please.
Simple algebra, all right? We just simply solve for R. R square is equal to R plus 2 is what? R square minus R minus 2 is equal to 0, right? এটাকে just factorize করবে, as simple as that, right? Factorize করে, what do you get? R minus 2 into R plus 1 is equal to 0, all right? So that means what? What are the roots of this equation? Guys?
2n minus 1.
2n minus 1. And 2n minus 1, as you can see, are distinct values. So this equation gives us two distinct roots. Since there are two distinct roots, we can use this theorem, okay? দুটা distinct root. The basis of this theorem is that there has to be two distinct roots for this characteristic equation. So we have that. So a theorem যদি use করি, then we will use this equation to define an, this equation. An is equal to alpha 1 into r1 to the power of n plus alpha 2 into r2 to the power of n. We know the value of r1 and r2. So ওগুলো just বসাবো এখানে. What happens there? r1 and r2 value বসাবো এখানে. So it transforms into this equation. An is equal to alpha 1 into 2 to the power of n, the first root, plus alpha 2 into minus 1 to the power of n, the second root. All right? So far, is everyone with me?
Yes.
Nice. Okay.
Yes, ma'am.
All right. So
Yes,
now
ma'am.
we have to solve for alpha 1 and alpha 2. We have to do that. We have to solve for alpha 1 and alpha 2. How will we do that? We will utilize the initial conditions. Okay. A first initial condition, jeta a0 equals to 2. What is the value of n here, guys? This one?
0.
0, exactly. So a equation tate, this equation, in this equation, if we put n is equal to 0, what happens? Left hand side, what do we get? A0, and we know that a0 is equal to 2. So left hand side is 2. Left hand side equals to 2.
Simultaneous equation solver.
Exactly. So right hand side, n এর value যদি 0 হয়, what do you get? Alpha 1 multiplied with what? To the power of 0, which is what? 1. So you get what here for the first sum term? Simply alpha 1. Exactly. Second sum term ta ki hoy? What happens to the second sum term, guys?
Alpha 2.
Alpha 2, exactly. So the equation we have is alpha 1 plus alpha 2 is equal to 2. However, that is not going to be enough to determine the value of alpha 1, alpha 2. We need another equation. How will we find the other equation? Utilize the second.
N equal to 1.
Exactly. N is equal to 1 এর জন্য. Utilize the second initial condition. If we use n is equal to 1, what happens to this equation? Left hand side becomes a1. We know from the initial condition that a1 is equal to 7. So left hand side we get 7. And what happens to the right hand side? 2 to the power of 1, it's 2. So 2 alpha 1. And here we have minus 1 whole to the power of 1. So minus 1. So 2 alpha 1 minus alpha 2. This is the equation you get. 2 alpha 1 minus alpha 2 is equal to 7. So we have alpha 1 plus alpha 2 equals to 2. 2 alpha 1 minus alpha 2 is equal to 7. Using these two equations, can we not solve for alpha 1 and alpha 2? Elimination method use koro, substitution use koro, whatever. Duta equation ache, duta variable ache. Can we not solve to find out the value of alpha 1 and alpha 2, guys?
Yes, we can.
Yes. I'm not going to through the process of that. That is not the purpose of this. Whatever method you use is up to you as well. You can even calculator directly equation gulo boshayo calculate korte paro. I don't care. All right. As long as you get the right values and you follow the correct process. All right. So if you solve for these two values, the variables alpha 1 and alpha 2, you get alpha 1 is equal to 3 and alpha 2 is equal to minus 1. And simply a value gulo kothay boshabo? A equation tate. A equation tate alpha 1 alpha 2 value boshabo. Then what do we get? An is equal to 3 into 2 to the power of n minus 1 to the power of n for all n greater than or equal to 0. Okay. Here in this equation, the only variable is n. All you need to do is know n. Whether n represents length or whether n represents index, shudumatra n janle, you can find out the value of n. So this is the solution to the recurrence relation. So let's say, for example, if you're given with a counting problem, একটা counting problem যদি দেয়া থাকে আর যদি বলা হয় to solve that problem using recurrence relation and to derive or to solve the recurrence relation further, what would you have to do? First, এই যে আগে যে এক্সাম্পল গুলো আছে এগুলোর মতো করে you would have to first find a recurrence relation. And obviously degree 2 এর recurrence relation হবে এরকম কোনো প্রবলেমই দেয়া হবে. So degree 2 এর recurrence relation যদি হয়ে থাকে, then you can use theorem A to solve that recurrence relation and the initial condition, combining them with the characteristic equation. And this equation, we can solve the recurrence relation and get this final expression, which calculates the value of n just from n itself. This one is not dependent on preceding values. All right. So is this clear? The procedure, entire procedure, is it clear, guys?
Yes, ma'am.
Okay. So using theorem A, that is how we could solve a recurrence relation. However, একটা problem আছে. Because theorem A completely depends on the assumption that the roots will be distinct. So root jodi distinct hoye thake, then you can use theorem A. এই যে A equation টা আমরা use করতে পেরেছি because the roots were distinct. What if the roots are not distinct? What if the roots are equal? You get equal roots. Let's say you have a recurrence relation of degree 2 where C2 will never be equal to 0. C2 equal to 0 hole to we won't get a situation where it's degree 2. So where and also equal roots হবে. So so assuming that C2 will never be equal to 0 for the sake of degree 2 where it's degree 2, so where and also equal roots হবে. So so assuming that C2 will never be equal to 0 for the same kind of recurrence relation of degree 2, the characteristic equation, if the characteristic equation yields roots of the same value, that is yields equal roots, in that case also we have a theorem, theorem B. This is the theorem we will use in order to solve recurrence relations which have characteristic equations which will yield equal roots. All right. So in that case, this recurrence relation which solves the sequence, this recurrence relation, this equation is equivalent to this equation. An is equal to alpha 1 into r0 to the power of n plus alpha 2 into n into r0 to the power of n. Previously, remember, we had alpha 1 into r1 to the power of n plus alpha 2 into r to the power of n. Here, first of all, since the roots are the same, we have only r0 here. Alpha 1 and alpha 2 are here. And in the second sum term, n is there as a factor in the second sum term as well, as a product term in the second sum term. All right. This is the equation we will use when the roots are equal. All right. For example, in this recurrence relation, guys, tell me, what is the value of C1, C2 in this recurrence relation?
C1 is 6 and C2 is -9.
Exactly. So what happens to the characteristic equation? What do we get for 6 and -9?
This r square equals to 6 minus 9. 6r minus 9.
R square is equal to 6r minus 9. Now, if you solve this equation, just like before, factorize square, you will see that it yields r is equal to 2. That is, the roots are equal. We have equal roots here. If it's equal roots, then we cannot use theorem A. We have to use theorem B. That is, we have to use this equation basically. All right. So A equation to use korle, then An is equal to alpha 1 into 3 to the power of n plus alpha 2 into n into 3 to the power of n. All right. A equation to use korte hobe. Now we have to solve for alpha 1, alpha 2. How will we solve for alpha 1, alpha 2? That is alpha 1, alpha 2 constant gulo kibhabe ber korbo? Again, just like before, use the initial conditions. Initial condition a0 equals to 1 er jonno n is equal to 0. If n is equal to 0, what happens here? The left hand side is a0. What is a0, guys? What is a0? Do we know the value of a0? Yes, we do. It's 1. So left hand side is equal to 1. What happens to the right hand side for n is equal to 0? Alpha 1 into 3 to the power of 0. What happens here? The first sum term, what do we get here?
Alpha 1.
What about the second sum term? What do we get in the second sum term?
0.
0.
0, because n is here as a factor in the second sum term. So n is equal to 0 jonno second sum term becomes 0. So basically, first sum term is alpha 1. So right hand side we have only alpha 1, and left hand side what do we have? A0, which is equal to 1. So basically, we can say alpha 1 is equal to 1. But we need to find alpha 2 as well. Alpha 2 ber korte hobe. So for that one, we will use initial condition, the second initial condition for n is equal to 1. N is equal to 1 is the initial condition. That's why we'll use that one. All right. So for n is equal to 1, left hand side is a1. a1 is equal to 6. We know that. So left hand side is 6. Right hand side, alpha 1 into 3 to the power of 1. So 3 alpha 1 plus what, guys? Plus what? What happens to the second sum term? What do we get for the second sum term? 3 alpha 2. Exactly. 3 alpha 2. Alpha 2 multiplied with 1. Alpha 2 multiplied with 1 for n is equal to 1 multiplied with 3 to the power of 1. So 3 alpha 2. So this is the equation you get. 3 alpha 1 plus 3 alpha 2 is equal to 6. So we know already the value of alpha 1. So from here, we can find the value of alpha 2 easily. Right? So alpha 2, we get 6, and we put those values in this equation, and we have solved the recurrence relation. And this equation exists for all non-negative integers n. That is for all n greater than or equal to 0. Answer one question for me. What if initial condition jeta deya ache, initial condition deya ache a1 or a2 jonno? a0, a1 deya nei, all right? For example, a recurrence relation ta, for this recurrence relation, okay, a recurrence relation ta initial condition jegulo ache, for this one, if you were to solve this recurrence relation, and you get an equation, oi equation ta after solving is valid for what values of n? For all non-negative integers, just like this one. এই যেখানে যে all non-negative integers n, again all non-negative integers n, will it be the same there? Can you tell me?
বুঝলাম না মিস।
ধরো এই ইনিশিয়াল কন্ডিশন এখানে তো a0 আর a1 এর জন্য দেয়া আছে, রাইট? ধরো তোমাকে এমন একটা রিকারেন্স রিলেশনের জন্য সলভ করতে বলা হচ্ছে, এমন একটা রিকারেন্স রিলেশন সলভ করতে বলা হচ্ছে যেখানে ইনিশিয়াল কন্ডিশন দেয়া হচ্ছে a1 and a2, not a0 a1, a1 and a2. In that case, after solving whatever equation you get, will it be for all non-negative integers n? That is my question. Will it
No,
be for all n greater than equal to 0? No, it won't be. তাহলে কি হবে? For what?
we need to figure out a0.
No. রিকারেন্স রিলেশনটা তো তোমাকে সলভ করতে হবে, মানে ইনিশিয়াল কন্ডিশন যেটা, ওটার বেসিস আমরা কি বুঝতে পারবো? দ্য লোয়েস্ট পসিবল ভ্যালুজ অফ n, রাইট? এখানে ইনিশিয়াল কন্ডিশন a0 a1 কেন দেয়া আছে? Why initial condition a0 আর a1 কেন দেয়া আছে? Why are these the initial conditions? Because these are the cases for the lowest possible values of n. Lowest possible value of n is 0 and the second one is 1. The next one is 1. That's why these are the initial conditions. Previous case, এই যে ধরো bit string এর যে এক্সাম্পলটা ছিল, ওটা যে রিকারেন্স রিলেশনটা বের করেছি, ওখানে ইনিশিয়াল কন্ডিশন a1 and a2 কেন? Because the lowest possible value of n is 1. Length তো, in this problem, in this specific problem, n represented the length. Lowest length কত? Length lowest কত হতে পারে? 1. So initial condition is what? Initial condition we have the lowest case is a1 and then a2. So that means what? N এর lowest possible value is 1. So while this recurrence relation is for all n greater than equal to 3, once you solve this equation using the techniques that we have seen now, whatever equation you get, that equation will not be valid for all non-negative integers n. Because n এর lowest value in that case is what? Is 1. So all non-negative integers এর মধ্যে, remember that 0 is there as well. Here, this equation is applicable for all non-negative integers n because the initial conditions are for what? a0, a1. এটা থেকে আমরা কি বুঝতে পারছি? The lowest possible value of n is 0. That's why n greater than equal to 0 here as well. Initial conditions a0, a1. That's why this equation for all n greater than equal to 0. However, initial condition যদি বলা হয় যে initial condition is a1, a2. a1 equals to something, a2 equals to something. ওটা দেখে তোমার কি বুঝতে হবে? That is the lowest in the base case.
Greater than equals to 1.
Exactly. And for the equation is valid for all positive integers n. That is n will be greater than equal to 1. Okay? For all integers n greater than equal to 1. So এই জিনিসটা মাথায় রাখতে হবে. This is just the last thing that I wanted to mention. So now if you're given a counting problem, if you solve that counting problem using recurrence relation and the relation you get is of degree 2, then you should also be able to solve that recurrence relation using theorem A or theorem B based on the roots of your characteristic equation. And once you solve them, you also have to define, because recurrence relation tar kintu n er value hocche giye greater than or equal to a different integer. For example, here n is greater than or equal to what? N is greater than or equal to 2. All right? Because এই যে এই recurrence relation এ a2 এর আগের ভ্যালু গুলো তো পসিবল না। a1 যদি চিন্তা করো তাহলে what do you get here? a1 চিন্তা করলে এখানে a0 হবে আর a-1 হবে। a-1 বলতে আমরা কিছু জানি নাকি? না। This recurrence relation is valid for all n greater than or equal to 2. However, this equation is valid for all n greater than equal to 0. All right? So ওই জিনিসটা তোমাদের figure out করতে হবে। From there to মানে ওই যে n এর যে লিমিটটা previously for the recurrence relation and now for the new equation, what is the range of n? If the lowest possible value is 0, then for all n greater than equal to 0. If the lowest possible value is 1, then for all n greater than equal to 1, and so on. All right? Any questions, guys?
Oh, miss.
Yes.
All right. So let's end the recording here. I hope now